Yes, hello grade 11s, how are you today? My name is Kamala. I am a tutor and educator for mathematics and physical sciences, grades 10 to 12. Today I want us to go through this November 2022 Physical Sciences Paper 2 from Eastern Cape to prepare you for your November as well. Those guys who are in Limpopo, yes, I send my greetings to my learners at Meridian, Capricorn, Nolderland. Yes, I want you to get total, okay? Now, I'm sure if you guys can get 100% in this paper, then you will be able to do all your scope, okay? So let's go. Our extra classes happen here at ROSTEC College in POLKWANE. Whenever you come to attend, you get a video. Okay, this multiple choice, they say, which one of the following is the name given to the reaction in which electrons are transferred from one substance to another? Is it a redox, precipitation, neutralization, decomposition? What is it? Note something here. They are saying that in which electrons are transferred. Did you hear that? Electrons are what? Transferred from one substance to another substance. So that's the most important thing here. So now to know our answer here, take an example of this. Take an example of this one here. Now here I have this sodium plus chlorine to form sodium chloride. Okay. Now you see this chlorine here, it's taking up electrons and it becomes chloride ions. Okay, meaning the chlorine is receiving electrons from sodium. So this is a half reduction equation. And then if you check properly, the one for sodium, then sodium, it gives off electrons to form sodium ion. Okay, so sodium gives off electrons. By the way, note something from the start that whenever we have electrons in the product side, it means this reaction, it gives off electrons. Why? Because they appear in the product side. So this is a half oxidation reaction. So now this oxidation reaction and this half reduction reaction, when we combine them, we got this reaction which is called a redox reaction. So that's why our answer here is going to be a redox reaction. It's going to be what? Redox reaction. Okay, all right, hope we are together. Redox meaning reduction and oxidation combined together. Let us proceed. Next question. The diagram below is used to demonstrate the differences between interatomic bonds, that's chemical bonds, and intermolecular forces. Okay, now before I proceed, I need to show something here, guys. This is methane. Now this is methane molecule, this one here which I'm surrounding here. This is methane molecule. Okay, now this methane molecule is combined with another methane molecule, this one here which you see. Okay, now the bond between the two molecules, because these are molecules, is called intermolecular force. Now this one which is within the same molecule, we call it interatomic force. So let us check the answer now. The question says the diagram below is used to demonstrate the difference between interatomic bonds and intermolecular force. So interatomic bonds and intermolecular. So the question is, which one of the following statement is correct? A, X is stronger than Y. Now this X is not stronger than Y. Okay, please understand that, because these are London forces. Okay, and these are covalent forces formed by sharing electrons. That's why this one is weaker than the one for Y. That's not correct. Then X is an interatomic bond. They're saying X is interatomic bond. Now this X, because it is between two molecules, you cannot say it is interatomic. No, that's not correct. X is intermolecular. Okay, then X is an intermolecular force. That is very correct. Now they're saying Y is intermolecular force, but you see Y is within one molecule, so it will say this is interatomic force, not intermolecular force. So the answer is X is an intermolecular force. Hope we are together. Let us proceed, guys. Let us proceed. Next, they say here that the minimum amount of energy needed for a chemical reaction to start is called activation energy, catalyst, heat of reaction, bond energy. Now look at the important thing here. They're saying that the minimum amount of energy needed to start a chemical reaction, we know it is called what? Activation energy. It's called activation energy. Somebody can say, teacher, what's a catalyst? A catalyst is a chemical substance which speeds up the rate of the chemical reaction. And what is heat of reaction? Heat of reaction is the difference between the heat of the products and that of reactants. Then what is bond energy? It's the energy enthalpy which is needed to break a bond or to form a bond. Okay, let us proceed. So here the answer is activation energy, guys. Let us proceed next. Consider the potential energy graph for the hypothetical reaction, that is 2P, to give us P2. Okay, now this is 2P is our reactant. 2P is our what? Is our reactant. Okay, so we have the reactant here. Together, reactant here. Then giving us the products. Okay, now the question says that the heat of the reaction delta H is represented by, now this side we have the heat, which is potential energy in kilojoules per mole. Here we have time. Okay, now this 2P, as you saw, it is the reactant, which means this corresponding Y must be the energy for the what? For the reactants. Then this is Z, which you see here, we call it activation energy. It's called what? Activation energy. Okay, that means from Y to Z, it's activation energy. And then this one here, what is the product? It means this is energy for the products. Energy for the what? For the products. What are the questions say? The heat of reaction is represented by, now please understand that heat of reaction is given by energy for the products minus energy for the reactants. It's given by what? Energy for the products minus energy for the reactants. So for that matter, my answer is going to be energy for the products minus energy for the reactants. Now if you check what we have here, then what are we talking about? We are saying here, now the product, it is this P2 all together. This P2, meaning this X is energy for the product, so we're saying X minus reactants, which is Y. Okay, so the answer is X minus Y here, guys. So mean that in this case my answer is going to be X minus Y, whereby it's going to be what? Who can talk to me? It's going to be B. So my answer is B. My answer is B. Hope we are together. That is heat of reaction given by energy for the reactants, that is X, minus energy for the products, which is Y. Let us proceed. Consider the incomplete reaction below. Okay, that is X plus HCl to give us a salt plus water. Which one of the following is correct regarding compound X? Now compound X is, now look at what we get. You're saying that when we react this X with an acid, they're saying we get a salt plus water. We get what? A salt plus water. So which means that in this case, when do we get a salt and a water? When do we get a salt and a water? Now, if you remember properly your theory, when you add a carbonate plus acid, you get what? A salt plus carbon dioxide gas as well. When you add a metal plus an acid, you get a salt plus hydrogen gas. But when you add a metal oxide plus an acid, you get a salt and water. So this is our answer here. It is B. I have an example here for you. Take this example here. When I add sodium oxide plus hydrochloric acid, I'm going to get sodium chloride, which is the salt, then plus water. So indeed, when I add a metal oxide plus an acid, I get a salt and water. So what is my answer here? My answer is C. Hope we are together. My answer is what? My answer is C. Okay. Alright. Any questions? Please, you can inbox me on 0785-222-041, or you can come to ROSTEC College in POLKWANE here for more information. However, I think we are together. Don't you think so? Let us continue. Next. They say consider the substances P, Q, and R. They say something important here. Note that they're saying P dissolves in Q but not in R. P dissolves in what? In Q but not in R. Okay, so then they said the most likely bonds or intermolecular forces in substances P, Q, and R are, we've got ionic bonds, dipole forces, London forces, dipole forces, ionic bonds, dipole forces, London forces, and ionic bond, then ionic bonds, London forces, and dipole forces. Now, remember we are starting with P, Q, and R. So they said P dissolves in R, okay, but not, rather P dissolves in Q, but not in R. Guys, check this out. Now, if I have sodium chloride and then water and then ethane. Now, this ethane, we're going to see more about it next month because our extra classes for grade 12 are starting next month in December 2022, where we have organic molecules. This is one of them we're going to look at. Now, this sodium chloride, it is ionic. This water, it is a polar molecule. And then the methane, the ethane here, because it is a non-polar, it has what we call as the London forces. Now, sodium chloride at home, you know, that's the common salt. You can dissolve it in water, but then does not dissolve the ethane. So actually it means that in this case our order should be ionic, because this is an ionic substance because of the sodium ions and chloride ions, and then this one it's a polar, so it has got what? It has what we call as the dipole forces, and then this one because it is a non-polar, it has what we call as London forces. So in this case our order should be what? Ionic, dipole forces, and London forces. In that case we see that we have something like, actually sodium chloride dissolves in water by this equation here. Again, we're going to see that when we come to extra classes next month, that is sodium chloride dissolving in water give us sodium ions plus chloride ions. Okay, all right, so our answer here is going to be what? It's going to be A. Why? Because P is ionic like sodium chloride, okay, and then Q, where it dissolves, is dipole, has got dipole forces, which is water, and then R, it is the one which doesn't have what, which only has London forces, which is not polar, non-polar. So the answer is actually A. Hope we are together. 1.7. According to the kinetic molecular theory, molecules of gases at the same temperature always have the same mass, volume, pressure, average EK. What's the answer? Let us look at important terms here. They are saying, according to kinetic molecular theory, molecules that have the same temperature, okay, and these are molecules of the gas. These are molecules of the what? Of the gas. Now, in our previous video, if you watched it yesterday, we said that at STP, all gases have got the same what? Same volume, which is 22,4. Okay, so in this case, but because we said STP, it means we said standard temperature and pressure. Now here it's only same temperature, and in this case it's not going to be volume, because for volume to happen to be the same, the molecules of the gas must have the same temperature as well as same pressure. So it's not volume this time, but instead it is average kinetic energy. Why? Because if they ask us in chemistry to define temperature, how do you define temperature? We say temperature is the average kinetic energy of the gas molecules. Do you remember that, guys? What is temperature? It is defined as the average kinetic energy of the gas what? Of the gas molecules. So temperature is the average kinetic energy of the gas molecules in a gaseous substance. So meaning that in this particular case, our answer is going to be what? It's going to be that one there. Okay, check it again. The question said that they have the same temperature, so they must have the same kinetic energy. So the answer is D. Hope we are together. If we are not, please feel free to ask. Consider the following compound, that is oxygen, water, hydronium ion. They say define the term molecule. Define the term molecule. So what is a molecule, guys? What is a molecule? Now a molecule, it is a group of two or more covalently bonded atoms that function as a unit. What is it? We're saying that a molecule, it is a group of two or more atoms bonded together that act as what? That act as a unit. Okay, that's how I define a molecule. Okay, then do the Lewis structures for oxygen and then water. Now note something, guys, that if you talk about Lewis structures, we use the symbol for the element and put it in the middle. Then outside it we put what we call as the valence electrons. Now what are valence electrons? Those are the ones which are found in the outermost shell. And how do we know them? We look at the group number. For groups 1, actually we look at the group number. Group 1 has got 1 valence electron, group 2, 2 electrons, group 3, 3 electrons, group 14, 4 electrons, 15, 5 electrons, 16, like oxygen, it only has 6. Okay, so because these are two oxygen atoms, now look here, guys. So it means that in this case, my answer is going to be like this. Okay, it's going to be like this. So okay, now I must have the oxygen, but then I must surround it with what? With the valence electrons. So oxygen, because there are two of them, these are two, that's 1 and 2. Now pay attention here, guys. Now for this oxygen atom, look here, this is 1, 2, 3, 4, 5, 6. Now because it's in group 16, that's why it has got 6 valence electrons. Okay, now this other one also has the same 6. I think you can see them here.
Are you there? Mr. Patrick?
Sir?
Hello?
Yes, I'm here.
Okay. That's fine.
All right, sir. Excuse me. Okay, I'm saying that now these two oxygen atoms, they are bonded because they want to become stable. Now when are they stable? When they have 80 electrons in the outermost shell. So in this case, these 4 which you see here, they are being shared amongst the 2 atoms. So now if I count for this, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. And then if I count for the other one now, for the other oxygen atom, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So you see, because they all have 8 in the outermost, it means they are stable. And this is called the Lewis structure for this oxygen molecule. Let us look at water. Let us look at water. Now water is H2O. It is H2O. And being H2O, it means it has got 2. It has got what? It has got 2 hydrogen atoms and then 1 oxygen atom. Okay. And now we have seen that oxygen is in group what? It is in group 16. Okay. So for that matter, it must have 6. Let us begin by putting them now. Okay. Let's put them now for oxygen. They are 6. Okay. Now I'm going to have this is 1, okay, this is 2, this is 3, this is 4, this is 5, and then 6, okay, because it's in group 16. Now this hydrogen, being in group 1, it only has 1, okay, so it contributes 1. So for hydrogen, It's going to contribute only 1 electron. Let me just put it in black. Okay, so this is what you see here. This is 1 for this hydrogen, and this is for this hydrogen here. So now what we see here, so to call the Lewis diagram for this water. Why? Because oxygen must have maximum of 8. Let's count them: 1, 2, 3, 4, 5, 6, 7, 8. So it is stable. Then hydrogen can only take up to maximum of 2. That's why there are only 2. Only 2 here. Actually, if I wanted to draw the structure for water, I would do something like this. It would be this one, like this, like this. Then I have got my hydrogen here and my hydrogen here. That's the water, which is H2O. This bond comes from these 2 electrons, and this bond came from these 2 which were shared as well. Hope we are together. Let us proceed, guys. They say the hydronium ions form when the oxygen atom in water donates its only pair of electrons into the vacant orbital of the proton. Write down the name of the type of bond described by the underlined phrase. They say donates its lone pair of electrons into the vacant orbital of the hydrogen ion. Okay. Now you see, this water has got the 2 lone pairs out together. So what happens is that one of the pairs is going to be used to attract this positive hydrogen ion. Okay, and in that case, when that happens, because the 2 bonding electrons are coming from only the water molecule, not the hydrogen, it means it has got a different name, and we call it what? A dative covalent bond. So this is its name. It's called what? Dative covalent bond. We also sometimes call it what? Coordinate covalent bond. Okay, they say draw the Lewis structure for the hydronium ion. Okay, now in this particular case, our structure for the hydronium ion is going to be like this. Okay, you see, we said that we had the water which was like this, out together. Now the hydronium, the proton has got a positive charge, so when it is joined up here, it's going to come with its overall charge. So it means that when I'm going to draw my Lewis for this hydronium, these are 3 hydrogens, to build something like this. Okay, watch this, guys. So for this case, now I must put my my electrons. Okay, so let me use this red one again. Note, oxygen must be having how many? Must be having 6, so this is 1. Okay, are we together? 2. Okay, and then 3. Okay, and then 4. Then here 5 and 6. Okay, now note something that in this case, the remaining pair here is attracting this proton, and because the incoming proton has got a positive charge, it means that in this case my overall structure is going to be positively charged like this. Okay, like this, positively charged like this. So I must cover it, must be what? Positively charged. It's no longer neutral. You know what is neutral, So I put here a positive what? Must put here a positive ion, meaning that is now my Lewis structure for this water molecule. Hope we are together. This is the proton which came in, which was attracted by the lone pair. Are we together? Remember that there were 2 which were available. Check here, they're still here. This one and this one here. So now I only have 1 which is left. The other one was used to bond to this what? To this hydrogen ion. Hope you are together. Now they say, which molecule is polar? Is it water or oxygen? Explain your answer. Now in this particular case, our answer is going to be, the one which is polar is going to be water. What about oxygen? It is non-polar. Okay, why? Now to get the polarity, we find electronegative difference. We find what? Electronegativity difference. Now for oxygen, if we check on our periodic table, for oxygen, because it's the same oxygen, it will give us 0. Okay. Then hydrogen and oxygen combined together, oxygen is more electronegative than what? Than hydrogen. So mean that oxygen will attract the bonding what? The bonding electrons. In that case, it will be what? It will become polar. So the difference in electronegativity is 0 for what? For the oxygen. This one, for this oxygen here, it's 0. But then for the water, it's because oxygen is more electronegative than what? Than the hydrogen atom. And so for that matter, it means it's going to be what? It's going to be the bond between the O and H is going to be a bond which is going to be polar. That's why it is oxygen which is polar, but water which is polar, but not oxygen, because with oxygen the difference is 0. Okay, let us proceed. I hope we are together. If you're not together, please feel free. You can inbox me or come at ROSTEC College where you have extra classes from. Okay, now next here, they say the table below shows the relation between melting points of 3 molecules, that is methane, CF4, CCl4, negative 182,5, negative 150, negative 23. Define the term melting point. What's melting point, guys? What's melting point? What is melting point? Talk to me, somebody. What's melting point? What's melting point? Now, melting point is defined as what? The temperature at which a solid and liquid are in equilibrium. Defined as what? The temperature at which the liquid and the solid phases are in what? They're in equilibrium. That's how we define melting point. The temperature at which the solid and liquid phases are in equilibrium. Okay, they say explain the trend in melting points of the molecules in the above table by referring to the intermolecular forces and the energies involved. Okay, now look here. First of all, from negative 182 to negative 150 to negative 23, it means melting point is increasing as you go down the table. That means increasing from methane to CF4 to CCl4. It is increasing. Now the question is, they want an explanation. They want what? An explanation. So this is how we explain it. Now in this case, because they all have carbon, it means we look at the hydrogen, fluorine, and the chlorine. Now hydrogen is the smallest, then this fluorine is bigger than hydrogen, fluorine bigger than fluorine. So the molecular size is increasing in all the three as you go down the table, meaning that this is the biggest, this is smaller, this is the smallest. Okay, so because all these are non-polar molecules which have got London forces between the molecules, and because of the increase in the sizes, that's why we're going to have an increase in the strength of the what? Of the London forces between the molecules from methane to carbon tetrachloride. Okay, you can say, write it down for us. It is here written down for you. Okay, so we are saying that this is the reason here that the molecular size increases from methane to carbon tetrachloride. Though all the three molecules have what? They have London forces. The strength of intermolecular forces increases with increase in molecular size. So more energy is required to overcome the stronger London forces, hence the high melting point down. Okay, hence what? The high melting point down the table. I repeat, we are saying that the molecular size increases from CH4 to CCl4. Though all the three molecules have London forces, the strength of intermolecular forces increases with the increase in what? In the molecular size. So it means more energy is required to overcome the stronger London forces as you go down the table. That's why there's a high melting point. Hope we are together. Next, they say here that which molecule in the table will have the highest vapor pressure at a given temperature? Now, the one with the highest vapor pressure at a given temperature is going to be done with the lowest melting point. Okay, because it's going to melt and then form the liquid and then start forming the vapor. So this one, which has got the lowest melting point, is going to have the highest what? Vapor pressure. Remember that for the liquid, for something to form vapor, it must first of all change from solid to liquid. After melting the liquid, then as you heat the liquid, you're going to start boiling that. You're going to start boiling that liquid, and then it's going to form pressure above the liquid. So down with a lower melting point will form more what? More vapor pressure than the rest. So our answer is going to be this one here. It's going to be this methane, which is CH4. Okay, CH4, because it's got what? It has got the lower. Answer is methane. Answer is methane. Okay. Why? Because it has got the lowest melting point. The lowest what? Melting point. Okay. All right. Hope we are still together. Let us proceed. Next. They say, explain the answer. Okay, we're done with that. They say here, question 3.4. What does the question say? They say that explain the answer. Okay, yeah, water is a smaller molecule than carbon tetrachloride, but water has a higher melting point than carbon tetrachloride. Explain this observation by referring to the type of intermolecular forces involved. Okay, now in this case, carbon tetrachloride has got weak London forces on between the molecules, and then water, in addition to the London forces, is what we call as hydrogen bonding between the molecules. So because of the strong hydrogen bonds between the water molecules, indeed it will have what? It will have a higher melting point than carbon tetrachloride. Hope we are together. Maybe you can say, write it down for us. It is here, just next door. Okay. So we are saying that yes, I'm saying this, that in this case, carbon tetrachloride, it has got what we call as weak London forces. But then water, that is H2O, it has both hydrogen bonds and what? And the London forces combined together. Okay, so this water is H2O. It has got both what? Hydrogen bonds and what? London forces. Hence, has got a high melting point. Okay, in water than in what? Than in carbon tetrachloride. That's why it has got a high melting point in water than in carbon tetrachloride. They say, write down the name of the intermolecular force that will exist in a mixture of water and the carbon tetrachloride. Now, water is a polar molecule. What about CCl4? It's a non-polar molecule. Now, when we have a polar and a non-polar molecule mixed up together, the force between them is called what? It is called dipole-induced dipole force. It's called what? Dipole-induced dipole force. So that's what we have here. It's called dipole-induced dipole force. That's the force of attraction which exists when you combine a polar substance with a non-polar. In this case, water is polar and this one is non-polar. So it's called what? Dipole-induced dipole force. Let us proceed, guys. Hope we are together. Question 4. A group of learners investigated the relation between pressure and the volume of an enclosed gas at room temperature. They recorded their results in the table below. This is pressure in kilopascals, volume, and then they say, for this investigation, write down the name of the gas law that is being investigated. Now the gas law which relates pressure and the volume at constant temperature is called what? It's called Boyle's law. It's called Boyle's law. It's called Boyle's law. So our answer there is what? It's Boyle's law. Hope we are together in this case. Called what? Boyle's law. Okay, that's called the Boyle's law. And then next, they say the controlled variable must be constant temperature, or the amount of gas. So we are controlling the temperature here, meaning we are keeping it constant. Okay, and then they say write down the relation between pressure and volume of the gas described by the first three data sets in the table. So check here, pressure 100,33, 102, 103. You see it is increasing. What about the volume? From 7,3 to 7,2 to 7,0. So as the pressure increases, the volume decreases. In other words, pressure and volume, they are inversely proportional to one another. So what's our relation? We said that they are what? They are inversely proportional to one another. So we said that the pressure of the gas is inversely what? Proportional to the volume of the gas. Is inversely what? Proportional to the volume of the gas. So that's our answer. That's our answer here. We're saying that the pressure of the gas is inversely what? Proportional to the volume of the gas. Hope we are together. Okay, they say calculate the value of x. Now this statement, if I want to say it using a formula, is called P1 V1 equals to P2 V2. So P1 V1, I just look at my table, I choose any set of data. If this is P1, it will be V1. If this is P1, it will be V2. So I can take the first one. I'm going to say P1 V1 equals to P2 times V2. So then I can get my x as well in that case, just by solving. Okay, so I'm going to say in this case P1 V1 equals to P2 V2, whereby my P1, like you saw, it is 100,33. What about V1? It is 7,34 equals to P2, that's x which I'm looking for, times V2 which is 6,97. And indeed when I solve this, as you can see, I get what? I get 105,66 kilopascals. Hope we are still together. Hope we are still what? Together. If you're not together, please don't hesitate. Just inbox me on 0785 222 041, and then I'll help you out. Or you can come at ROSTEC College in POLKWANE for extra classes. Don't forget that our grade 12 extra class begin next month in December 2022, because we want to teach you all the grade 12 work from the start, so they can always be ahead of your teacher at your school at a very minimum cost of only 500 rands per month per subject. We do math and physics. Okay, let us proceed here. Write down two conditions under which real gases behave more like what? Ideal gases. Now we only have two conditions for real gas to behave as an ideal gas. In this case, the condition we have it's at high temperatures and the low what? And the low pressures. High temperature and the what? And low pressures. So that's our answer. So at very high temperatures and low pressures, the real gases behave as ideal gases. Okay. And then next question, they say here that I'll write down the name of a gas. Write down the name of the gas whose behavior is close to that of an ideal gas under conditions mentioned above here. So the gases here, we can have helium or hydrogen. These are very good gases. They can behave as ideal gases, okay, under those conditions. That means at a high temperature and a low pressures. Hope we are still together, guys. Okay. You're writing on Monday, others on the 25th, so as the 28th, so please practice this. I'm sure it will help you in your test. Okay, next we have an organic compound has the following composition by mass, that is element, then percentage here, carbon, hydrogen, oxygen. This is 54,55, 9,09, 36,36. The molar mass of the compound is twice the empirical molar mass. Define the empirical formula. What is empirical formula? Anybody who remembers that? What's empirical formula? Empirical formula is the simplest whole number ratio in which atoms do what? Combine in a compound, okay? What's empirical formula? It is the simplest whole number ratio in which atoms in a compound combine, okay? So empirical formula is what? It's the simplest whole number ratio in which atoms in a compound combine. Okay. Next, they say that determine by calculation the molecular formula of the compound. Now they have said that the molar mass of the compound is twice the empirical formula. Did you hear that? So let us get the empirical formula first, then multiply it by 2 to give us our what? To give us our molar mass. Now to do so, we write down the compounds, okay? Rather the elements and then the corresponding masses, and then after that we find the what? We find the moles. After getting moles, then we find the molar ratios. After getting molar ratios, then we find the simplest molar ratio, which will give us the empirical formula. So in this case, this is what happens here. So if you check what they gave us carbon, hydrogen and oxygen. The mass given was 54,55. What about hydrogen? 9,09. What about oxygen? 36,36. So to get the number of moles, we say number of moles equals to mass over molar mass, okay? Equals to what? Mass over molar mass. And then you see here, I'm going to say 54,55 divided by 12. What about hydrogen? I'm going to divide by 1 because hydrogen has got mass of 1. What about oxygen? It has got 16 divided by 16 here. So after dividing by the molar masses, I get these ratios here. Now to get the simplest, I divide by the lowest number, which is 2,77. And when I do so here, I get 2 here and 3 here and then 1 here. So after getting this as my empirical formula, to get my molecular formula, because they said it is twice, I multiply this one by 2. Now empirical formula, it means I've got 2 for this hydrocarbon, I've got 3 for this hydrogen, and I have 1 for this oxygen. That's why it is C2H3O1. So to get molecular formula, I do have to multiply by 2. What is 2 times 2? I get 4. 2 times 3, I get 6. 2 times 1, I get 2. That's why my answer is going to be what? C4H6O2. Hope we are together. If we are not, you should come and inquire, okay? Otherwise we are moving on. They say a teacher demonstrates to a group of learners the impact that the limiting reagent has on the amount of product formed during chemical reaction. So this is my equation here: zinc plus 2HCl to give me zinc chloride plus hydrogen gas. The teacher uses the following setup for the investigation. Okay, that's good, teacher. Then we have this one here. We have experiment 1, 7 grams of zinc, 1 mole of HCl. Experiment 2, 3,27 grams of zinc, then 1 mole of HCl. Define the term limiting reagent. What is limiting reagent? Now, a limiting reagent is a substance which is used up completely in what? In a chemical reaction. Say it again. It is a substance that is completely used up in a chemical reaction. So they say determine the limiting reagent. Next, they say determine what? Determine the limiting reagent in experiment 1. So 7 grams of zinc and then 1 mole of HCl. So to get my limiting reagent, this is what I do. I first get my moles of zinc by dividing by 65, which gives 0.11 moles. Then again, that moles of HCl, we have 1 moles available. Okay. If I look at my mole ratio, which I get from this equation here, this is 1 zinc plus then 2 HCl, that's 1 to 2. I can see that if I check what I have here, for zinc I have got 0.11 moles, okay? And now let me find out the one which is needed for HCl by putting X here. So after putting X here, I cross multiply. X times 1, I get X. 2 times 0.11, I get 0.22. Now I can say that 0.22 moles is what is required to use up the 0.11 moles. Okay, but check what is available. I have 1. So because 1 is bigger than 0.22, which is required, means this HCl is in excess. So therefore, it means zinc is my limiting what? Reagent. Hope we are together. Zinc is my what? Limiting reagent. Okay, let us proceed. Next on the queue, they say, how will the amount of zinc chloride produced in experiment 2 compare to that of experiment 1? Write down only higher than, lower than, or equals to. Now, the amount of zinc chloride, which the product, it must depend on the limiting reagent. Did you hear that? Let me say it again. I'm saying that the amount of the product, which is zinc chloride, must depend on what? On the limiting reagent. Why? The one which is X is going to be misleading because we don't have enough zinc. So if you look at my experiment 1, the zinc here is 7. What about here? It is 3. So because I'm reducing the zinc, which is limiting, it means I will have a low output of the what? Of the zinc chloride. So it will be lower than, because first of all, it is zinc which is more in experiment 1 than experiment 2, and the zinc is my limiting what? My limiting reagent. So the answer is going to be lower than. Hope we are together. The answer will be what? Lower than. Okay, the answer is lower than. Okay, then next they said that next we do what? Okay, this answer I'll put it here. So we are saying it is lower than because zinc is limiting. Okay, zinc is limiting the reagent, and of course we see there's more of zinc in experiment 1 than experiment 2. That's why zinc is limiting, and so we're gonna say it's gonna be lower than. Okay, next question they say, experiment 2 was carried out at 4 degrees Celsius. The molar volume of the hydrogen gas at this temperature is what? 25.7 decimeters cubed. They say, calculate the volume of the hydrogen gas produced once the reaction reaches completion. Now let us check our equation again. Our equation again, we have, they're saying we need volume of hydrogen gas produced. Okay. Now if you look at our equation again, it is zinc plus 2 HCl to give us zinc chloride plus hydrogen gas. So now because I have this hydrogen gas and then zinc, you see the mole ratio is 1 to 1, which means if I can get moles of zinc to be the same moles as that of hydrogen gas, because of what? 1 to 1 mole ratio. Because they gave me the mass here, which is 3.27, I can use N equals to mass over molar mass to get what? To get my moles of zinc, which will be the same moles as that of hydrogen gas, because the mole ratio is 1 to 1. Okay, that's why I do like this. Okay, in this case, I work it out like this. Okay, so after getting my moles of zinc, dividing here, I get 0.05 moles. And then the moles of zinc are the same as those of hydrogen because of what? 1 to 1 mole ratio. Now the formula, we said yesterday again that the number of moles equals to V divided by V molar. So I can get my volume by saying V equals to V times V molar. This gave us 25.7. So it gives us 1.285 decimeters cubed as our answer for the volume of hydrogen gas produced. Hope we are together. Then next we have here this question here. They say, consider the following reaction of HCl, that is hydrogen chloride plus water, to give us chloride plus hydronium ion. Define an acid in terms of Lorentz model. What's an acid, guys? Talk to me now. An acid is what? It's a proton donor, right? It's a proton donor. It is a proton donor. Okay, it's a proton donor. Okay, that's an acid in Brussels roaring. Okay, and then next they said that write down one conjugate acid-base pair. Listen carefully here, guys. Now the conjugate acid-base pairs differ from one another by proton. Okay, but this is how we identify them. Pay attention here, guys. We talked about this in our previous video. I'm sure you watched it as well. If you don't watch it, just inbox me and I send you the link. Okay, now I want to get my conjugate acid-base pair. Check here, guys. So if I look at my HCl, this is HCl. this HCl becomes Cl minus, meaning it has lost a proton. So because it lost a proton, it becomes my SDA1. My SDA1. Now after losing the proton, it becomes the conjugate base, B1. Did you hear that? When the acid loses a proton, it becomes what? A conjugate base. Now look at this water here. This water, it's H2. What happened to it now? It gained a proton. So because I have this base already, now the water becomes my second base, which is I call base B2. Call it what? Base B2. Now after water getting a proton, it forms what we call as the conjugate acid, which is acid A2. Okay. So now this question here says write down the conjugate acid base pair, which means a learner can write A1, B1, or they can write B2 and A2, which means my answer I'm gonna say here, I'm gonna say HCl, okay, HCl, and what? And Cl minus. This is my pair. It's correct. All I can say water and then hydronium, and they're both correct because they wanted what? A conjugate acid base pair. But note something, that if the teacher only asks for the bases in this equation, look for B1 and B2. Did you hear that? If the teacher only asks for the acids, look for A1 and A2. Hope we are together. We discussed this in detail in our previous video about conjugate acid base pairs. Let's write down the formula for the substance in the reaction that can act as an amphibole in some reactions. Now this water is capable of donating a proton and also receiving. Here it has received, but can donate to form OH minus. So it is an amphibole. In this case, my answer is H2O. My answer is what? H2O here. My answer is H2O. That's water. Okay, H2O. And then next they said that a certain volume of hydrochloric acid solution of concentration 0.5 moles is added to a sample of seashells of mass 8 grams in a container. Hydrochloric acid solution completely reacts with the calcium carbonate in the sample according to the balanced equation below. Okay, that is so nice. This is our equation here. They said that the seashell contains 95% calcium carbonate. They say is the reaction endo-electrothermic. Now this delta H minus means that the heat, it means that the reaction gives off heat. So, and when the reaction gives off heat, it means it's called what? It's called exothermic. So my answer here is what, guys? It is exothermic. Why? Because my delta H is less than 0. Okay, because what? My delta H is what? Less than 0. That means the net heat change is negative. So delta H less than 0, it means it is what? It is exothermic. Hope we are together. Let's calculate the volume of in centimeters of the hydrochloric acid that was added to the sample inside the container. Okay, now I want to find out the volume of HCl that was added to the what? To the sample inside the container. Now note something, they said that the acid solution reacts completely. Okay, reacts completely with the calcium carbonate, which means all the calcium carbonate is consumed. Are we together? So because I have got here, they say the seashell they contain 95% calcium carbonate, and I want the volume of HCl. It means I must first get to know the moles of HCl, which I'm going to get to know after getting the moles of the calcium carbonate, because I have the mass. The mass here is what? It is 8 grams for the what they say the seashells of mass is 8 grams container. Okay, this is the mass here. Now this is the mass for the seashells, but they contain a right percentage, which is 95% of calcium carbonate, which means that to get my answer here, please get your calculators out. I'm going to need them now. I need first get the mass of calcium carbonate, right? The mass of what? Calcium carbonate. Okay, so it's going to be what? 95%. Let's get it, guys. Calculators, help me out there. I'm going to first get my mass of calcium carbonate, okay, which is going to be what? Which is going to be 95%, that's 0.95. 0.95 times the 8 grams. What do we get? Anybody with a calculator? Help me, please. 0.95 times 8. I get here 7.6 grams. Okay, get 7.6 grams. 7.6 grams. Okay. After getting the mass now, I'm going to get the number of moles. Number of moles equals to mass over molar mass, right? Mass over molar mass. So it's going to be 7.6, okay, grams divided by molar mass of calcium carbonate. Now calcium carbonate, let us get the molar mass for calcium carbonate. What is the mass for calcium? We can check out the periodic table here. Calcium. Oh, calcium, what's its molar mass? Jesus. What is it now? I want for calcium. Okay. There's my periodic table now. Okay. Yeah, now it's in the right position now. Now, because I need calcium carbonate to get your calculators out, let's calculate it together. Now, calcium, if you check here, it is 40. So I'm going to say 40. I'm going to say 40. What about carbon? That is 12 for carbon. You can see carbon has got 12 here. And then what about oxygen? Plus open bracket, that is 3 times 16, which gives us what? 100. So I get my molar mass as what? As 100. So when I come back to my table here, I divide by 100, right? So divide by what? By 100 here. So what do you get? 0, what? 0.076 moles. Okay. Now if I check my reaction now, the mole ratio of calcium carbonate and then HCl, it is 1 to 2. Okay, 1 to 2. So I'm going to say mole ratio is 1 to 2. 1 to 2. Now the one is for the calcium carbonate, which is 0.076. So this is 0.076. Now the one for HCl I don't know, so I can call it to be X. Then I'm going to cross multiply here. Now X times 1 I get X. So X is going to be equal to 2 times 0.76. What do you get? 2 times 0.076, we get what? We get 0.152. 0.152, get 0.152. 0.152, okay? After getting this, now these are the moles of HCl. These are the moles of what? Of HCl. Now if I have the moles of HCl, and the question wants me to get the volume, what must I do? They gave me the concentration. Do you remember that? What's our concentration, guys? It is this one here. They say it is 0.5 moles per decimeter cubed. So if I know the concentration, then I can get my what? My volume, because I know that C equals to N over V, right? C equals to N over V. I have 0.5 as my concentration. What about my N? It is 0.152, okay? Divided by what? Divided by V. So in this case, if I cross multiply, I'm going to get my volume equals to 0.152 divided by what? By 0.5. Anybody with a calculator, get me the answer, please. Divided by 0.15, 0.5 rather, yes. I get 0,304 decimeters cubed. 0,304 0,304 decimeters cubed. Now this is the volume of HCl which was added inside the container. Hope we are together, guys. Okay. All right. Let us proceed. Our last question for today. They say here that consider the advanced redox reaction below. This one here. Okay. Then they say define oxidation. What is oxidation? It's a reaction which involves the transfer of electrons from one substance to another. I say it again. The reaction involving the transfer of electrons from what? From one substance to another. Must I write it down for you? Okay, why not? They're saying that it's the reaction, okay, which involves the transfer of electrons from one substance to another. Okay, so that's a redox reaction. Okay, then next they said that oh, they wanted oxidation. Okay, I beg your pardon, guys. What is oxidation? Oxidation is the loss of electrons. Oxidation is what? Oxidation is loss of electrons. Oxidation is the loss of electrons. Okay, and then now next what do they want? That's oxidation. Now they say that for the balanced equation, I will write down the reduction half reaction. So this is copper solid plus silver ion to give us copper 2 plus silver. So reduction, you see this silver has been reduced to silver with 0. This is from positive 1 to 0, which means this is going to be our reduction half reaction. Okay, so it's going to be Ag plus, it is reduction, so it's going to be Ag plus, that is Ag plus, Ag, that means Ag plus an electron to give us what? To give us silver, which is just like that. That's our reduction. Then what about the reducing agent? Now you see the reducing agent and the oxidizing agent, they must be one of the reactants. Now, because it is silver ion which has been reduced to silver, it means it has been reduced by this copper. So our copper is the reducing agent in this case. That means this Cu solid is a reducing what agent? This Cu solid is the reducing agent. Okay. Then this explanation for the answer by finding the oxidation numbers. Now, if you look at our copper, it has been oxidized from 0. This is copper 0 because it's not combined, to copper 2. So, because of the increase in oxidation state from copper 0 oxidation state, okay, to copper 2, which is this Cu2 plus, that's why it means this copper, it is the one which is the what? Reducing agent. Why? Because if they say define a reducing agent, we say that it is a substance which is oxidized in a redox reaction. So this copper was oxidized to copper 2. That's why it is a reducing agent. Now they said the following complete chemical equation represents a redox reaction. Here we have the dichromate plus iron 2 to give us chromium 3 ions plus iron 3 ions. Determine the oxidation number of chromium in dichromate ion. Okay. Now I want oxidation number in this case. So if you check properly, guys, here, to get my oxidation number for chromium in here, these are 2 chromium atoms. So if it is X for 1 chromium, it's going to be 2X here. So to get my oxidation number, I do the calculation. I can say, because there are 2 chromiums, it's going to be 2X. It's going to be 2X, okay. It's going to be 2X, okay. And then plus. Now oxygen has got 2 minus, but there's a 7 here. So plus 2 plus 7, okay, multiplied by -2, because oxygen's got -2, then must be equated to the overall charge, which is -2 here. Okay, so what is 7 times -2? I get -14, -14 equals -2. So -14 becomes what? -14 becomes positive. So what's -2 plus 14, guys? I get positive 12. I divide by 2 both sides, which gives me x equals to what? X equals to positive 6. So my answer, it is positive 6 here, which means that oxidation number for chromium is positive 6. Okay, in this dichromate ion. Then there's using information from the table standard reduction potentials, write down the balanced net ionic reaction. Clearly indicate the following. We need a reduction half reaction, then oxidation half reaction, then the balanced net ionic equation. So now that chromium, I know it has been reduced from positive 6 to positive 3. About iron has been oxidized from positive 2 to positive 3. So I'm going to combine those two half reactions to get my net ionic equation. So let me start with iron because it's simple here. Now iron is getting from iron 2 to iron 3 and has been oxidized. So it means my equation is going to be like this. It's going to be iron 2 ions, okay, then it is oxidized, okay, it's going to give me, decide what? It gives me iron 3 ions, okay, then plus an electron, okay, because it has been oxidized. Now the dichromate, I see it gives me what? Chromium, but I can't claim this, so I must use my what? My reduction potential. So check something that when we go there, we're going to look for what? We're going to look for the following. We're going to look for the dichromate ion being reduced to give us what? Chromium ions. That must be in mind, okay? Let's check it now. Dichromate to give us chromium. Now if I check here again on my table 4b, now this is my table 4b here, guys. I need where dichromate is reduced to what? To chromium 3 ions. If I check properly here, where is it? Anybody who sees it? Dichromate to give me chromium 3 ions. Where is it? Jesus, come on. Yeah, I see it here. So I see it here. So this is dichromate, okay, this one here, giving me chromium. So I must write this equation. There. This is my reduction half equation. So dichromate plus 14 plus 6 electrons. Did you hear that? Dichromate plus 14 plus 6 what? Protons. Let's write it now. What did I say? I said we are going to have the dichromate ion. Dichromate, that is C. Okay, sorry. Yes, I'm going to have dichromate, dichromate ion. That was plus what? Plus 14 protons, Plus 14 protons. And then plus how many electrons? Plus 6 electrons, okay, to give us what? The chromium ion and some other stuff. We're going to check again. Let's check plus what? Chromium plus, let's check it again. Plus 7 water, so plus 7 water. That's 2 chromium plus 7 water. So this is 2 chromium. This is 2 chromium plus 7 water. Now, note something here, guys. To get our overall, we must balance the electrons. Because these are 6, it means I must multiply this equation by 6 as well. So I'm going to multiply my first equation by 6. So what is 6 times 1? I get 6 here. Okay. 6 times 1, I get 6 here as well. 6 times 1, I get 6 here as well. After having 6 electrons at this side, and 6 this side, now I can add to get the overall net ionic equation, which the question wants me to get. Let's get it together. So I'm going to have 6 ion 2 up here together. I'm going to get what? 6 ion 2, 6 ion 2 ions, okay, and then plus dichromate. I think you see that is Cr2 or 7 with the 2 minus, then plus 14 protons, okay. Now electrons, they're going to cancel out, why? Because they are the same and they appear on different sides of the equation, okay. And then to give me what? To give me 6 and 3, that is 6 and 3, 6 and 3 ions, and then plus what? Plus 2 chromium ions, plus 2 chromium ions, 2 chromium 3 ions, okay. Then plus 7 water, plus 7 water, plus 7 water. So this is our overall net ionic equation. Now I can say that thank you, Jesus, for doing this, okay. Thank you so much for watching. My name once again is Kamala. I am a tutor and educator for mathematics and physical sciences grades 10 to 12. Now extra classes begin next month for grade 12 and 11 only here at ROSTEC in POLKWANE, and it's only 500 rands per month. So if you're interested after passing your test on Monday, please, you can join us, or you can inbox me on 0785222041. Thank you so much for watching. Catch you again in my next video. Bye bye.